afternoon, everyone. It's good to see so many people here today. It's my pleasure to introduce our speaker, Professor Joe Sussman, who has a many-page, short resume here. So to allow Joe enough time to give a talk, I'm going to just pick some highlights from his short CV. Joe is very distinguished. He has won a number of awards, including the Roy W. Crum Distinguished Service Award from TRB. It is TRB's highest honor for significant contributions to research. He has also won the CUTC Award for Distinguished Contribution to University Transportation Education and Research. He was, in 2002, ITS Massachusetts named its annual Joseph M. Sussman Leadership Award in Joe's honor. In addition, here at MIT, I think everyone knows that Joe is central, a cornerstone to transportation activities, both research and education here at MIT. So it is my pleasure to introduce Joe. Thanks for
Thank you, Cindy, and thanks to so many of my friends from MIT, from the Volpe Center, and possibly other places coming here to hear what I have to say, speaking on the general topic of transportation in contemporary society, looking at it from a complex systems point of view. So we, of course, during virtually every lecture that we've had in this seminar series going back to last semester have talked about the importance, the fundamental importance of transportation in society, contemporary or otherwise, central to the economic development of nations around the world and improving the quality of life of the world's citizens as we experience economic growth as a result of transportation. I argue, though, that we're in an environment now where we are really being challenged as transportation professionals as we never have been before, and this challenge is brought on by a variety of kinds of complexity that we've either been able to ignore in the past or have chosen to ignore in the past, but now has become so central that we must now explicitly consider it. And I'll try and make the case as we proceed through this next hour or so for those different kinds of complexities and why they make our life as challenging as it is. So the fundamental construct of this talk is to speak of different eras in the world of transportation, what I call the infrastructure era, the transportation systems era, and then finally what I call the transportation as Kleos systems era. Now everybody here knows what infrastructure is, and everybody knows what a transportation system is, or you should. Many of you will not have any idea what transportation as a Kleos system means. So before I get into the trajectory from infrastructure to the current day, let me just say a word or two about Kleos. This is a concept that's been worked on by my graduate students and me for about 5 or 6 years now. The idea of a so-called Kleos system and the Kleos process that we use to study such systems. That's not the topic of today's talk. That's a story for another day, what that Kleos process is. But just for definitional purposes, we talk about Kleos systems as being complex on a variety of dimensions, being large scale, typically large scale in terms of geography, but also large scale in terms of impact, interconnected in the sense that transportation as a Kleos system is interconnected with other Kleos systems like the energy system, the environmental system, the economic development system, that it is that these systems are open in the sense that we explicitly have to consider social, political, economic, and institutional factors when we try to study them. and they are socio-technical. That is, at least in my world of the Kleos process, these systems have an important technological component, but also relate to society quite directly, hence socio-technical. A system with no technological content would not qualify, and a system where we were unconcerned with the social aspects of it wouldn't qualify either. And as I say, the Kleos process, which we've developed, is used to study Kleos systems, and I've had a number of thesis students and others over the years use this process to study a broad set of systems, not limited, incidentally, to transportation systems. So that serves as a definition. And putting this in a broader context, some of you have seen this chart in other talks, but we speak about the evolution of the field of engineering from engineering science as developed in the 1950s and early 1960s. Engineering science has been an important foundation of engineering research, education, and practice. It is typically built around the traditional physical sciences, physics, mathematics, chemistry, to have a strong base for engineering to build upon, as opposed to a base pre-World War II that was primarily empirical in nature. And we've argued, in particular in the Engineering Systems Division of MIT, we've argued that this approach has netted us a great deal, that it has a lot of value. It tends, though, to be microscopic in scale, reductionist in scale. It focuses on the idea of mechanics, solid mechanics, fluid mechanics, and the like, as the underlying disciplines of importance. And we've argued in recent years that one has to get beyond that there are contributions that have been made that we can utilize, but now we need to define the idea of engineering systems, taking a step back from the technology, the microscopic view of technology, and be concerned about how systems, or a system in its entirety, behaves. So emergent behavior that might occur in a complex system. So taking more of a broad view, a more systemic view of behavior, as opposed to the more taking a more integrative view as opposed to the more reductionist view in engineering science. And we're not arguing either or, we're arguing that one has to balance these two to approach the kinds of problems we're interested in. And the engineering systems motif here at MIT, if you will, has been characterized as kind of the Venn diagram intersection of management, social science, and engineering, that we work at that nexus, bringing technologies from the transportation field, but leavening it with the perspectives of management and the perspectives of a variety of social sciences, political science, economics, sociology, and the like. So that kind of puts Kleos in the context of a broader approach to what we call engineering systems. And with all that as background, we now ask the question that's at the core of what I want to talk about today. Can complex engineering systems provide a new and valuable lens on our field of transportation? We and I and many people in this room have worked on transportation for many, many years. The question is, do we have something new coming at this when we think about transportation as a complex engineering system? And I'm not sure I have the answer, but we shall see. I personally am living at the interface of transportation and complex systems with my appointments both in civil and environmental engineering and also in the Engineering Systems Division at the Institute. So back to the eras that I want to talk about with all that as background: the infrastructure era, the transportation systems era, and the transportation as Kleos system era. I personalize these and line them up in some sense with my own educational process and my own evolution, professional evolution over time. It's a bit egotistical to do it in that frame, but it gives me kind of some stakes in the ground. Rather than arguing about when each of these occurred, I relate them to different educational aspects of my life. Back in the 1950s, when I was an undergraduate at City College of New York, CCNY, I would argue we were in the infrastructure era, where the fundamental tenet of transportation was infrastructure and building it. When I came to MIT as a grad student in the mid-1960s, I would suggest we were at that time, in some sense, inventing transportation in the systems era. And I argue now, in the 21st century, the early years still of the 21st century, we've now evolved to transportation as a Clio system as our frame of reference. So let's talk about each of these eras. I'll talk about the first two relatively briefly, and I'll talk about the Clio's perspective more extensively. The infrastructure era, back now in the 1950s nominally, was, of course, the time at which the interstate system here in the United States was just getting underway, with President Eisenhower signing the legislation in the mid-1950s, leading to an extraordinary investment in intercity, and it turned out urban highways as well. And I would argue that the ethos in those days, when I was, again, an undergraduate, was within the transportation field, it was our job as engineers to build what, quote, they want, build what we felt the public wanted. And what the public wanted, we felt, was mobility, mobility on demand, if you will, being able to go wherever you wanted to, whenever you wanted to, relatively free of congestion. The notion here was this kind of universal mobility as what we were about. We were taught, when I was an undergraduate, the idea of so-called desire lines. One would put on a map the lines between point pairs that people wanted to travel between, and then basically leapt to the conclusion that if we had a desire line between those 2 points, we should build a road for people as a way of satisfying that demand. So build what they want. Our focus, my undergraduate education, was on physical facilities. How do you choose a material? How thick should the pavement be? And other physical design issues. The focus was entirely on mobility, that is, getting people where they wanted as quickly as possible, and I'll contrast that with the broader idea of accessibility in a moment. The focus of transportation investment was pure and simple economic growth. The reason we are building this transportation infrastructure, be it highways or other kinds of infrastructure, was to create economic growth, to raise GDP per capita, to make people richer and then presumably happier as well. And the perspective was largely a modal perspective. You were a highway person, you were a public transportation person, you were an air person. People specialized within particular modes, and the idea of interconnections among those modes was largely ignored. So now we fast forward for about 7 or 8 or 10 years, and we move into the transportation systems era. Now this was, as I said, in my egotistical way, I'm equating that with my arrival at MIT as a graduate student. And we had people in those days around here like Marvin Mannheim, the late Marvin Mannheim, the late Chef Lang, Marty Wohl, and others who were pioneers in this idea of thinking more systemically about the transportation system. So now, rather than simply drawing lines on maps and saying we need a road here, there was a more economics-based framework for understanding transportation decision-making. We talked about supply functions, particular pieces of infrastructure providing for transportation. We talked about doing more sophisticated demand analysis, trying to understand how demand related to supply through the concept of equilibrium. And rather than thinking about individual links, individual projects, we began thinking in a more systemic way about networks as the output of what a transportation system design might be. We had broadened by this time our focus on beyond economic development, as it was in the infrastructure era, to environmental concerns, which related to what was going on in the real world. Rachel Carson, the Silent Spring, Ralph Nader, Unsafe at Any Speed. There was a much broader public concern with the impacts of transportation beyond the benefits that might accrue economically. There were disbenefits as well. So the notion here is we had to take a broader view. One couldn't simply say, hey, we're building this stuff because it's going to grow the nation economically. We had to be concerned about the idea of environmental impacts of a variety of sorts. We focus now not only on mobility, we still wanted to get people around, but we worried about the theme of accessibility as well. And we've heard in the discussions of transportation at MIT that Dean Barnhart has given, the idea of accessibility being a broader concept, not simply worrying about getting bodies from one place to another, but worrying about accessibility to destinations that people actually wanted to go. So we had broadened our concept to this, and the idea of the interplay between transportation and land use became a fundamental pillar of what we were thinking about. We began to understand that problems were being caused in the transportation system as a result of what we called and still call unpriced externalities. That is, the impacts that were being caused in terms of congestion, air quality, and sprawl related to the fact that externalities that were being generated by individual users of the transportation system were unpriced. The price signal was in effect broken. So when somebody chooses to drive to work rather than taking public transportation, there is an air quality impact, but that person who made the choice to drive doesn't, in any direct sense, pay for the cost of the air quality degradation that he or she is causing, and the same arguments can be made for congestion, for sprawl, and so on. So we were starting to get a more sophisticated view of what the transportation system was about. And we had then a broadening to an intermodal perspective, recognizing that modes were good for different things, and interconnections between modes might well be a more effective way of providing transportation services. So the idea that, for example, a freight move using rail and truck and a container ship crossing the Atlantic or the Pacific Ocean might well present a very good cost level of service point for freight shippers, where being and limiting yourself to a single mode would not give you the same opportunities. So in those days, intermodalism was on our mind, but in practice, it was largely limited to freight. We'll see that we have now, in more recent years, broadened that to an understanding of intermodalism in the passenger transportation in the passenger transportation perspective as well. So now, finally, we're in transportation as CLEO's system. We're defining transportation as this broader, more complex characterization of the transportation world. We're thinking about transportation where we are today, the early 20th century, requires us to think about complexity in a variety of ways as we go about doing our designs, doing our analyses, making our decisions. So complexity appears in a variety of guises. One could, of course, give a talk on just the question of how complexity and why complexity appears or arises in particular circumstances. But just to give you a flavor of it, complexity appears in systems like CLEO systems, the transportation system, because of uncertainty, that is stochasticity. We can't know the future, and those uncertainties are important. We see nonlinear behaviors in many of these systems, which again makes analysis and prediction quite difficult. We often have difficulty in this complex environment relating cause to effect, to effect, and we have feedback, including time delays in that feedback, all of which create an environment in which it's very difficult to know what will happen if we disturb a system in a particular way. We're concerned within complexity about what we call the micro-macro behavior question, the question of the level of detail we need to understand the microscopic behavior underlying a system to the macroscopic behavior that we are ultimately concerned about. We're concerned about different kinds of time scales. You've got systems that operate at different time scales. In the case of a transportation system, perhaps one can change a bus schedule very, very quickly in the course of a week or two, but the time scales related to, for example, changes in land use may take decades to occur. We are concerned about long and short-term behaviors. One can very often come up with fixes on a system that work very well in the short term, but in the longer terms lead to even worse behaviors than we have now. And the definition of boundaries, that is, within what framework, within what system, what boundaries are we considering the behaviors that are of interest to us. And the broader we make those boundaries, the more complex it is to understand. So Complexity 101, and now we talk about complexities that we observe of many different types. Here are four. There are others that one might consider. We talk about structural complexity. There are large numbers of components in a system. The numbers of interconnections among them are substantial. So from a structural point of view, we have systems that are indeed quite complex. It's difficult to understand all the interrelationships. That kind of structural complexity gives us behavioral complexity. Behaviors emerge from that structural complexity. We call those emergent behaviors indeed. And it occurs as a result of sets of components that interact in ways that we find very difficult to trace. And behavioral complexity makes prediction very, very difficult, in some cases essentially impossible. We have what I call evaluative complexity. We have the competing perspectives of many different stakeholders with many different points of view. So even if we could wish away behavioral complexity, we would know exactly what would happen if we intervened in a particular system. That wouldn't necessarily mean we knew what we should do. So if one looks at the addition of runway capacity to Logan International Airport, you could imagine somebody living out in the suburbs saying, that sounds like a terrific idea to me. I'm going to get a better level of service from that facility. But somebody who lives in East Boston who's being impacted by the noise and other impacts of Logan International Airport may view that further expansion of that facility in quite a negative way. So even if we could predict with certainty what would happen at Logan and what would happen more broadly to the air system if we added, say, runway capacity to Logan, even if we could do it, and of course typically we can't, we still wouldn't know whether we should do it because of evaluative complexity, the views of different stakeholders weighing different levels, different measures of performance in a different way. Finally, we have what I have called nested complexity, the idea that we have a physical system that is in some way encapsulated in an institutional sphere, the institutional sphere made up typically of organizations, both formal and informal, and we're trying to manage a complex physical system with a organizational structure that may be on some dimensions even more complex. So back about 10 years ago, 8 years ago, when we were studying the transportation system of Mexico City, it had a great deal of physical complexity, all sorts of modes and different kinds of vehicles and so on and so forth running around that enormous metropolitan area. And one was trying to think about how one could improve the operation of that system but one had an institutional sphere with complexities that made actually managing improvement very, very difficult. So nested complexity, shown graphically here as a physical system, as a plane, and an institutional sphere surrounding it, presents a kind of complexity that often we haven't had to deal with in earlier simple days, when the complexities of the organizational systems tended to be rather static. But now we see in contemporary society a quite dynamic institutional sphere, which makes our task even more difficult. So that gives you a sense of various kinds of complexity. And now we move into what I mean when I talk about transportation as a complex, large-scale, interconnected, open, socio-technical, that is, CLIO system. We argue that transportation in this construct has several characteristics. It's characterized by increasingly advanced technologies and mathematical methods, in some ways enabled by those technologies. It's characterized by institutional change, and a concept that's been pioneered here at MIT, the concept of what we call enterprise architecture. It's characterized by an explicit connection of transportation to other socio-technical systems. I've mentioned energy and the environment, for example. It's characterized by an expanded role for stakeholders. Stakeholders now play at this table. That wasn't always the case. Certainly in the infrastructure era, it was not, and even in the transportation systems era, it was only moderately. But now political momentum has led to an expanded role for these stakeholders, sometimes for better and sometimes for worse. And indeed, we even more broadly define who the interested stakeholders might be. And we talk about macro design performance considerations, where we've gone beyond thinking about the transportation enterprise performance being measured in simple terms, travel time reliability, loss and damage, to a broader set of considerations, with which my colleague Joel Moses calls the ilities, flexibility, reliability, and the like. And we'll get into more detail about that near the end of the talk. So now let me take you through each of those characterizations and get into something a bit more detailed. The first of those characterizations was advanced technology and mathematics in the CLIO system era, and that enables a lot of different kinds of things that were very difficult, if not impossible, to do in the past. First of all, it has created a tremendous impetus for an operations focus in looking at transportation systems, and in particular, a real-time operations focus. Back in the infrastructure era, even in the transportation systems era, we were concerned about creating the transportation network, but the absence of information in real time, or sometimes in any time, about how the system operated, the absence of that information, caused us to focus on that initial design. Now we spend much more time with technologies like intelligent transportation systems doing a more operations-oriented focus on our transportation system, making real-time judgments about how it ought to operate. Hand in glove with that is the notion of tailored customer service. In the highway area, we've only quite recently begun to think about, first of all, that the people that use highways are customers, and second, that one can provide different levels of service on the basis of concepts like willingness to pay. The airline industry has long since done this in various ways by creating different classes of service as a function of the kinds of, and paying different amounts of money for it. For example, making reservations in advance and so on and so forth. But in the highway industry, the idea has not caught on until in recent years we started to realize that with concepts such as high occupancy toll lanes, where we can provide a better level of service for people, say people driving alone, who could use the high occupancy vehicle lanes for an additional fee. We are weighing willingness to pay with the kind of service that is being provided to that particular customer. We have a very rich information environment. We have, in some sense, an overwhelming amount of information. We can use it effectively, we can use it ineffectively. Obviously, we'd prefer to use it effectively, but thinking through how one is going to use that information for better decision making as part of transportation in this modern era. We now have the ability through technologies to have a much more effective level of intermodalism, since information technology allows us to, for example, link up the operation of a trucker with the operation of a railroad to provide a more reliable connection between those two modes. The Achilles heel of intermodalism, as many people here well know, is that while the modes may operate very well, the handoff from one mode to the other may not, and the information environment that we now live in lowers the probability of those kinds of problems. And we have seen in recent years an extension of what we're doing intermodally to not only talk about the transportation perspective, but to talk about supply chain management, to extend the system that we are concerned with into the inventory and manufacturing system that connects to transportation, again, enabled by the kinds of technology and mathematics that we have. Large-scale optimization, we now solve problems of a scale that would have been inconceivable 5 or 10 years ago. Dean Barnhart herself, as a matter of fact, has worked on very large-scale airline network problems that would have been unthinkable in a simpler technology era. So one now can use those kinds of technologies to solve problems that were beyond our scope in years past. Continuing with these enabling technologies in mathematics, we have disaggregate demand analysis as opposed to the more simplistic demand analyses that we've done in the past, again enabled by these concepts. The idea of real-time network control, again, ITS comes to mind, and provision of traveler information in real time. The notion of the automation of vehicles, and that can go to quite an extent, as we've seen in recent months. As a matter of fact, some of Toyota's vehicles seem to be automated to accelerate in unexpected ways. But vehicle automation, in the sense of safety, sensing people in the blind spot, and so on and so forth, can have substantial value. And changing the paradigm in highway safety in particular toward a crash avoidance rather than a crash worthiness perspective. For years and years, and even to the current day, crash worthiness of vehicles was viewed as the fundamental way to enhance safety, but now the idea of avoiding the crash altogether with advanced technology has changed our basic mindset in this time frame. Sophisticated pricing, yield management, allowing us to manage our revenues. The airline industry has pioneered in this. Pricing of externalities as well. We talked about unpriced externalities. Now we have the ability to price those externalities, at least to an extent, and that's extended into congestion management, for example. So we have ways of managing the system. And finally, the idea with the information technologies and mathematics that we have available to us, the idea of thinking of transportation as a regionally scaled enterprise, going beyond urban transportation or even urban and suburban to the metro-based region concept, and managing our transportation programs at that scale. And that has the effect of aligning us much more with the economists who have long talked about the idea of the region, the metro-based region as the economic engine of society. We've never managed transportation at that level, but now we have the capability of doing so. The second major thrust of transportation in the Clio system era was institutional change. And I commented before when we were talking about nested complexity that we lived through a very long period, decades, in which institutional roles and responsibilities were basically static. The public sector did what it did, the private sector did what it did, and never the twain will meet. The federal government had particular roles, the state and local governments had particular roles. It stayed remarkably stable for a long time. And one can argue now that we've seen some important changes in those relationships. So we've seen changes in the public sector, that is, among and within various levels of government. We've seen some fundamental shifts, particularly with emphasis on operations rather than infrastructure, between the federal government and state and local governments. The private sector is now much more of a player in areas that we have traditionally thought of as public sector. So you've got organizations like IBM and high technology organizations participating in transportation. So we have players beyond the traditional providers of conventional infrastructure, so new private sector players, and a new set of relationships between the public and private sector. Public-private partnerships is something that is, in transportation, is slowly starting to make some inroads here in the United States. It's, of course, been a part and parcel of transportation in many other parts of the world. And the idea here of appropriately sharing risks between public and private sectors allows us to consider projects that might have been very difficult for a variety of reasons to consider in the past. So we have these changes in the institutional structure. We think now on a much more international and global scale than we ever had to before. And we have to think about the challenge of operating regionally with advanced technology. So on the previous, in the previous discussion, I blithely talked about the idea of managing transportation at a regional scale enabled by the new technologies that we have. But now I show you the other side of the coin, actually accomplishing that within the complex institutional relationships that exist within regions. Look at the Boston metro area and the different perspectives of the various suburban towns surrounding Boston, and you can get some idea about the difficulties in actually trying to operate at a broader geographical scale. It may, in fact, make a lot of sense, but it's not always clear that you can convince the stakeholders that it does. We talk about the idea of logistics, supply chain management. We relate it to the idea of regional strategic transportation planning. The first of those being typically a public sector, the first of those being typically a private sector endeavor, logistics and supply chain. The second being a public sector kind of role for strategic transportation planning. How one relates those was the topic of a master's thesis done for me a few years ago, and it continues to be an institutional challenge. Transportation, in the third major category, transportation connected to other socio-technical systems. You've all heard us talk about the connection between environment and transportation, energy, economic development. Global climate change is something that within the last decade has become critical. And the notion of national defense and geopolitics. We have a connection through the energy sector, for example, with decisions we make in the defense community about investments we might make and even conflicts we might get engaged in to protect, for example, energy supply. So understanding at a subtle level and on a broader level how all these interact is important. We talked about stakeholders when we talked about evaluative complexity, and the idea that different stakeholders may have a different point of view about the same system and may measure its performance quite differently. A lot of research that's gone on at MIT as well as other places suggests that involving a broad set of stakeholders very early in the process may have a great deal of value if one is concerned ultimately about deployment. So we talk about involving stakeholders in system definition and representation. I had a doctoral student a few years ago, Ali Mostashari, in the Engineering Systems Division, who studied not a transportation project, but looked at Cape Wind, the idea of a wind farm in Nantucket Sound, and he actually was able to create an environment in which he had a stakeholder-driven representation of that system as opposed to a technocratic, that is, Corps of Engineers representation of that system, and was able to demonstrate, at least to my satisfaction, that the representation involving the stakeholders was inherently superior, which would lead, in fact, subsequently to the idea of developing strategic alternatives for the particular system of interest that would, in fact, be superior as a result of the representation being superior. Implementation strategies would, of course, involve stakeholders, and we've long since known that stakeholders who are involved early on are much more likely to buy into implementation strategies, having felt they had a place at the table, and even making decisions about those systems. The final point of departure for transportation as in the Clio system era is the idea of more macro design performance considerations when one thinks about the transportation enterprise. The ilities, we go beyond cost, level of service, and so on to consider more macroscopic characterizations of performance. Is the system flexible? That is, can it accommodate to, for example, different conditions, different levels of demand? Is it adaptable? Robustness is an ility, although it obviously doesn't end in ility. And I gave this talk or something like it in Japan and got myself in very deep trouble by talking about ilities and then saying, well, robustness isn't an ility, and everyone's kind of looking at me like, what is this guy talking about? Maybe you are too. But these various macro performance measures, flexibility and so forth, modularity, and then finally, perhaps the most important ility, certainly in my personal view, the most important ility, the idea of sustainability. And in some of our work, we've tried to promote the idea within the transportation field of sustainability as what I would call an overarching design principle. Now, let me be clear. This is a Joe Sussman opinion. I didn't carry this down with chiseled into tablets from Mount Sinai. This is my point of view, that when we talk about transportation systems and when we consider all the changes that we are dealing with in the Clio system era, that sustainability, a balanced view of economic development, environmental protection, and social equity is the mindset that we should bring to the table when we consider those kinds of designs. The economic development that may occur as a result of transportation decision-making, if not equitably shared throughout the society, economically and geographically, is, in my view, not sustainable. So the idea of seeing economic growth occur is entirely reasonable, done in such a way that the environment is protected, but people have to share it in an equitable way. Whoops. I guess my picture went away. That's one of these blame Bill Gates kinds of things. There was something that showed the T-shaped professional, but you can imagine what a T looks like, so I'll skip over that. So the idea of finally how transportation must change, in my view, in academia. And I've used some of these charts in other domains at other universities where, in fact, perhaps less progress has been made on this dimension than has been made here on MIT, at MIT, but let's at least talk about these change elements that we need to deal with transportation as a Clio system. The idea that transportation must reach beyond engineering to manage management, social science, and planning. I'd argue that we've done a reasonable job at the Institute here. It's not something that is generally in place in schools. The notion that we do something that we call qualitative analysis in addition to quantitative analysis. I've had an infinite number of conversations with colleagues who have used the word analysis, and I say to them, you mean quantitative analysis? And they look at me and they say, what other kind is there? And the notion here that there can be a qualitative analysis, for example, when one is trying to understand institutional structures and their impact, that has relevance too, is still a work in progress. That we need to learn, both educationally and in research, that we should avoid, eschew narrow representations of complex systems so that we can formally solve them. The economics profession for years and years and years used linear representations of economic situations, not because they believed the situations were, but because they could solve the linear equations and they couldn't solve the nonlinear equations. And I'm arguing that narrowing a problem space to such a level that you can now solve the problem, the math works, may lead to answers that have very little relevance to what we're trying to deal with. We must realize, in my view, that in many of these complex systems that what we would call an optimal solution is something we shouldn't even really think very seriously about, that in fact in practice they are beyond the pale, that we're often fortunate if we can come up with a reasonable set of feasible solutions, never mind optimal, to select among. And that's often all we can hope for because of this idea of evaluative complexity, because of the idea that people look at what optimal means in very, very different ways. It drives it makes solutions in an optimal sense much more difficult. Many of you have heard me talk about humility before, and this is another opportunity, that we as transportation systems people, or CLIOS people, need to be very humble in the way we go about intervening in complex socio-technical domains. It's very hard. It's in essence impossible to predict what our interventions will lead to. So we have an ethical responsibility to be very cautious and certainly humble when we do make that intervention. So I would urge that kind of behavior on us, given that the behavioral complexity of the systems we deal with makes our predictions extraordinarily difficult. And finally, relating our work in education and research to those of colleagues in other domains, energy, manufacturing, logistics, telecom. These are all CLIO systems too. I give MIT relatively high grades in reaching out and in fact being in some ways seminal in building these kinds of relationships. We all have our take on history, but my sense is that transportation back in the 1960s recognized some of these systems issues before some of these other fields did, but they might have a different perspective. So now really finally, I know I've said finally a couple of times and then continue to proceed, Ken Orsky, who writes Innovations News Briefs, a very well-informed Washington newsletter, and many of us know Ken Orsky, in a recent brief talked about, can we come up with a vision for the 21st century? And he bemoaned the fact that we weren't getting very far with the public continuing to evoke these awful crises that were going to befall the world, the country, and so forth. But rather, we should be, in some sense, more positive about what we can accomplish through transportation rather than the woe is me perspective that we seem to adopt. So we need to develop that vision in the context of many of the complexity types that we've discussed here today. And this is, of course, a non-trivial undertaking. So I can give you some elements of what I might think are part of what that vision might be. I don't doubt that others could add effectively to this list. My vision is a multimodal vision. One has to consider not single mode solutions, but designs that incorporate many different modes, both in passenger and freight. I'll come back to my sustainability idea, that sustainability is part of that vision as an overarching design principle, that we have to, within that vision, recognize our interconnections, but also leverage those connections, leverage our connections to energy, the environment, and so on. We will continue to be a technology-intensive business. We should build that vision on advanced technology. We should recognize that one can't predict the future, never mind with certainty. Sometimes we can't predict it even to directionally or to first order, and therefore our vision should value flexibility such that we can move in different directions as the future plays out. Will certainly require institutional change, continued institutional change. The organizational structures in some ways are extraordinarily counterproductive, but that institutional change, which we sometimes say is the soft stuff when we talk about comparing it with technology, but in terms of getting something done, it's the hard stuff, and making those changes is a difficult and long-range issue. And that we need to recognize complexity in all the forms that I've mentioned and doubtless others that I have not. And we should create this vision. We should have professional confidence in doing it. We've got a lot of very talented people, many of them here in this room, studying transportation. So we should have the confidence of the intellectual horsepower we bring to these issues, but yet in a humble way, recognizing we're dealing with a very, very difficult problem. So that's it. I appreciate your attention, and Cindy, if we have time, we can be open for questions or comments.
Yeah, thank you, John.
Yeah, Larry. This is Professor Larry Susskind. He and I have been getting each other's mail for about 40 years now, so.
First, thank you very much, Joe, and I'm both educated and quite comfortable with the frame you present. The question for me has to do with the normative stand that you think the education in this new era should take. Not just relative to what is the fairness, the third E in sustainability, supposed to be achieving, but even with regard to all the other items on your list. Don't use the word ethics anywhere. Presumably, you can't go to this, I'm presuming you can't go to this last slide you had up there without being more explicit in the educational frame about the ought or the normative side of things, which then seems to me to force those of us teaching to have to either say, well, my personal ethics take me here, or our institutional stand is, or some other way of sorting what it is you think is the right thing to achieve. Because once you move in those eras from methods of analysis to frames of more complex systems in which you describe and analyze to something more concerned about the consequences, how do you know where you stand, and how do you think the institution defines where it stands with regard to these hard normative problems?
It is certainly normative. That is unashamedly normative, and certainly I didn't use the word equity, but to be concerned with, I didn't use the word ethics, but if one is going to talk about the third E, social equity, one is implicitly talking about an ethical judgment on which people of goodwill can disagree. So what we as educators can do, I think, is basically lay out what the issues are, what the trade-offs are. I think it's entirely reasonable in the context of the classroom to indicate what one thinks one's own ethical views on particular questions are, as long as one makes it explicit, that one is not presenting received wisdom, one is presenting one's own view, and recognizing that other people in the room may have different views and may well parse out the balance between, say, economics and equity in a different way. But one, I think, has a responsibility to lay out those issues to our students. They're very intelligent, and as long as one says this isn't how it is, this is one way of thinking about it, and you should make your own judgment. Even people who believe in social equity may come up with very different definitions of it. I think it's a reasonable way forward. Other questions? I've stunned you into silence, all right? Yes. Yes, Aviva.
How can you budget for such a complex Clio approach? How do you budget transportation, surface transportation, the modes are still there, air transportation, they all competing. How do you...
You budget in a financial way, you mean?
Congress give us enough resources to maintain and renew this Clio?
Well, I think Congress, you want to talk about institutional issues and dysfunctional institutions. One doesn't have to go much beyond Congress when Senator Bunning can stop the United States government as a minority of one for 3 days on critical legislation. Institutional dysfunction, regardless of what his point of view was, is obvious. I think that what you have to consider is certainly there are political issues, and there are pork barrel issues, and there are bridges to nowhere, and so on and so forth. We may be able to work at that at the margin. It's not going to change in a substantial way. But I would go back to the comments of Orsky in the very last several charts I used, that perhaps Congress and perhaps the American public is very tired of hearing about woe is me and the Texas Transportation Institute congestion indices and so on and so forth. And what they want to hear is something like a vision of where we might go. Now, President Eisenhower, and before that General Eisenhower, had the concept of an interstate system. One could argue, and people in fact do argue to this day, about whether that was an appropriate development for this nation. I happen to personally believe it is, but you can find many who would disagree. But that was a vision. Yes, it was developed in such a way that you had interstate highways going through Wyoming and every state in the Union, so there was political savvy in putting it together, but it was a visionary view of where the field might go. And I would argue that we're badly lacking that today, that we're thinking about micro problems, we're thinking on a modal level, we're not thinking in an adventuresome way about technological innovation, that a vision, I think, would be much more effective in capturing the view, the attention of the American public, which is, of course, a prerequisite to capturing the attention of Congress. Now, people like you and people like Secretary LaHood, who, by the way, will be here on May the 3rd to give a talk here at MIT. I'll have to talk to him about nested complexity before he actually gets here. You've got to deal with the practicalities of getting monies flowing for appropriate purposes, and we have to continue doing that. But I think within the research community and within the senior level of government officials, one has to be thinking in a more visionary way. Yes, Fred.
Joe, I really enjoyed this presentation a lot. I guess
Thank you.
I want to disagree a little bit, although I admire your use of the term humility. But it seems to me that part of the problem that we're facing in interacting with other disciplines, other parts of MIT, is that the back in the early system approach with Chef Lang and the people who decided, the economics department had people who talked about externalities. They had people who focused on macroeconomics. The standard texts focused on macroeconomics.
Right.
The field, partly because of this tendency of people to want to deal with issues they can analyze with the tools at hand, have more and more gone over to the micro. When I ask students, have you taken economics, many hands go up. And I say, how many of you have taken macroeconomics? No hands go up. I gave a guest lecture at Boston College with a bunch of MBEs seeking a master's degree. I asked them for a definition of externality. They couldn't define it, they had never heard the term. So there's a real problem here, and to jump to the arrogant side, in the past, civil engineers have often invented approaches to dealing with problems where there weren't fields that were dealing adequately with the practical problems that they needed to solve. It's pretty arrogant to say the economists aren't doing the brand we need right now, so let's do our own. That's probably not going to work. But there needs to be a more aggressive poke in the ribs to our friends on the other side of the campus to say, what you're doing is useless to what we're trying to do here. There have to be some. I just want to, in the spirit of a little crave attention here, you're a very nice person, that's why we all love you, and you're humble, but maybe you're being too humble. You've got a big message here that a lot of these fields have gotten into stuff that simply are too small to matter, and that we need to be focusing on the bigger issues, and that these kind of lots of micro analyses are leading us kind of over a cliff. Either we invent our own other realms, which is not a practical solution, or we engage some other people around this institute to take these on in a different way. It's my opinion. I love what you're doing here, but I think you're being a little bit too humble, is my suggestion.
Well, it's like people come out of the seminar and they say, I heard Joe Sussman talking about humility, and the other person says, well, he's got a lot to be humble about. Perhaps the humility I'm talking about is humility in terms of understanding how we can make constructive change. Certainly being intellectually more aggressive is always on the agenda, I think. We've had a singular lack of success. I don't know if we have any Course 14 people in the audience, but we've had a singular lack of success on the scale of decades in getting the economists to pay very much attention to what we are interested in. I once heard one of them say, putting the word transportation in front of economist is like putting the word horse in front of doctor. It's just not, at the elite, I'm going to win a Nobel Prize level. It's not going to happen. So, yes, those are issues, and yes, we'll continue to fight them. I think we, to a certain extent, grow our own expertise in this area. I think growing our expertise in such a way that we can get somebody through the tenure process is candidly quite unlikely, but that's not to say that we can't have expertise that contributes to what we are, contributes to what we're doing.
Just to go back to the vision from President Eisenhower, the reason they went pay-as-you-go instead of toll-based triumphs was they did their analyses and concluded they would never build more than a third of the system if they went pay-as-you-go. By doing the entire system, as a person who fought certain lengths of interstate highway, as a system, that's an incredible success. As an implementation strategy, it's brilliant. That scale of approach to a problem is impossible when you're thinking microeconomics, what's the next 2 inches like? We only go 1/8 of an inch along the demand curve, and then we run out of. There's got to be. And I don't think we can invent our own. You're right. We'll never get them through tenure. But we've got to engage some other people and say, hey guys, this is not useful.
No, I agree. Bringing more intellectual
So
capital
a
to the
little less
problem.
humility, Joe.
So if you can turn that around to a positive again, like you were working so hard to do. But I think this might be a good opportunity to close this official part of the afternoon. We do have some drinks and skis and food outside to continue the dialogue. Thank you, Joe.
Thank you.